Salam and good day. So we're going to proceed with the lecture. For this topic, we are going to talk about the program control. Uh, just to look at the title itself, right? This is how you're going to control your program, because in the projects, right, in the end of the semester, you are going to develop your own project, right? So you are going to write the codes, and this code must work as what do you want to do, and it will involve then how you're going to control your program. Okay, so that's why this chapter we are going to talk about the program control. So the objective of this lesson is actually the student need to understand and can differentiate between the conditional and unconditional program control instructions, and later you are going to apply it in your program and you are going to understand how it works. Okay, let's look. Previously, when you work on learn about the C++ programming or any computer language programming, right? You are going to learn about the process of drawing the flowchart, and this is common for most of the program, where you have to draw your flowchart first, right? And then you're going to write the codes based on your flowchart. So normally this is a process. So you are going to look at the like for example, like when you draw the flowchart symbol, there will be a different or unique what you call it, the shapes, which represents what you're going to do. For example, here the rectangle here is like this is going to do a process, and then this is actually two rectangles on top of each other. So this is about subroutine, and maybe this is not a rectangle, this is something like trapezium, right? This is like the input or the output. And you also have this diamond shape. This is where you are going to make a decisions. So remember that, for example, decision is very simple. When you are going to use it, normally in the C++, right, you're going to use the if-else statement. You're checking the condition before you make a decisions. So that another one, you have the oval shape. This one is normally for the start and end, and later maybe you got the connector between A. If your flowchart is very big in drawing, so you have to go to the second page, that this one will go like this, right? Okay, this is another one, right? Example here, like this is the method that you write down your program, right? So this is how to draw the flowchart, and this is normally when you are drawing the flowchart, and then you have the flow of your program. So this is actually this is example, like a sequence means that it's from the top to the bottom, so it will execute one by one. So for this one is based on the condition itself. This is like if-else statement. So once it's go to this condition, right, you will check the status, where do you want to go, here or here. So like this sequence is directly going from the top to the bottom. So this is going to be make a decisions. After here, you are going to go for the right one or the left one. Same goes like this one. This is yes or no. Maybe you are going to check the conditions, and maybe you can skip if you are not doing anything. This is a part of the flowchart control. And this is also like the repetition. This is sequence, results, and repetition, right? This is the one. You can see based on this one, you are going to go back to the top of the program and do it again. This is like a repetitions, like a checking a loop. So this is like this one also. So this is like doing something else, checking whether you want to go down or you want to make it another checking on the top, like a looping again. All right, this is a control structure. Okay, this is a chart symbol, and this is how you control your program. So you know where you want to go from the top to the bottom. So we are going to learn about those syntax over here in program control. Okay, there are generally there are two types of control, where one is conditional branch and the second one is unconditional branch. This is normally the two main area that you need to understand, where the rest is about the subroutine or return jump. This is nearly the same, can be part of the program control, but we're going to learn most of it from here. Okay, so the syntax related to the program control, you can see here is just like an alphabet here. This is a symbolic for something else, right? So in assembly, right, it's quite hard for you to understand the alphabet, right? Just look at the alphabet, you need to understand what is it. But in C++, right, you know that it's very simple because the language is higher. So you can see the if and else statement over there, so you kind of can imagine what you want to write down. So here you have to understand correctly one by one. So you have to refer, if there is a table for this particular syntax for the control instructions, you have to check because this is going to be based basically on the syntax for the unconditional branch. Just very simple. For the conditional branch, you will have to check the flags, where you learn about the flags, the what you call the 5 flags that you learned before. That will be the one will be checked before you do some jump or control inter from your program, right? Okay, let's look at the first one. Okay, program instructions. Before we go that, okay, this is the one. This program instruction, right, is actually represented by 8 or 16-bit displacement. So what does it mean is, for the 8-bit displacement, right, it will permit transfer to locations up to 1 to 7 forward and negative 1 to 8 behind. So for this case, you just need to understand that for the 8-bit displacement, so only 8-bit displacement means that your 2 to the power 8 is 256, right? So if you are going to jump down, okay, branch up and branch down, so you are allowed up to 1 to 7 forward and negative 1 to 8, right? This is the 256A. This is positive, right? So this is the area that you can jump. Okay, so where do you want to jump? Based on where you want to go, up or down. Okay, same goes to this one. This is for 16-bit displacement permit transfer, locations up to this one. So you have to go for 2 to the power 16 is equivalent to, hold on, let me check. 2 to the power 16 is equivalent to 65536. 65536. If you divide by 2, is equivalent to 32767 678. So it can jump up to positive 32767 forward, or going down negative 32768. So this is the transfer permit transfer for the location based on the displacement that it shows. So we're going to look at one by one here. Okay, the first one, we are going to look at the unconditional branch. So we go back to the types of it. Here the point control instruction can be divided to conditional branch, unconditional branch, jump, and subroutine call and subroutine. So we are going to look at these two basically here. Okay, so the first one is unconditional branch. Okay, so this is the branch always. Okay, this instruction will go for the BRA. BRA stands for branch. Okay, this is branch always. Okay, is unconditionally, where it will always execute. If you use branch, it will always go to that particular branching label. So when you want to write the branch, you must have the label where you want to go. Alright, so this is the one that the what you call it, the parameter, or the one that we learned just now, 8-bit or same displacement. So you can look at later when we run the program, right? So this instruction affects the point counter by offset value. Okay, we are going to look at the example. So what is this? So this is point counter. Okay, the latest one, when you jump, you will have the current point counter plus the offset. So how to get the offset? The offset is based on the target address minus current point counter. This is point counter. Target address minus, this is the bracket, instruction branch address plus 2. So this is the formula where you can get the offset. Okay, let's go down. Before we go to this particular calculations, I just want to show you guys how we can look at the branch. Okay, branch statement here, how to use that one. Okay, let's look at the command here. Let's try, for example, that you have a command like just a very simple one, move.by hash $, right, bb to d1, all right, move dot towards hash $, ccdd to d2. Again, you have another one, move.by hash $12 to d3. Okay, if you have only this particular command, right, so you are going to just execute an end. For example, like this one, just we go to this one, execute. All right, just close everything that which is not needed. Okay, here when you execute the line here, so you look at the program counter, now is checking the 1000. This is where you are going to load and run the execution. 1000 starts from here, so we're going to run this one, this command, and then we go to 1004, which is this one. 1004 now is going to be executed, right? So this is going to d2, go again, and then this is 1008. So this is the one for the program counter is pointing to this one. Then it will execute this line and then finish, no more. So it's a one-time deal, going down, because your program is going to execute from top to bottom. So let's try to run a branch. When you want to run a branch, means that you must label where do you want to branch. For example, here you are going to branch main line. So main, you must state that this is the label where do you want to start back to this particular program. So in this case example, I want to put this label main over here, and then we are going to make it like this. All right, so we execute it again. All right, so now we run this one. Right, it will go down. This is the same one just now, no issues. 1004, execute. Right, now 1008, execute. Now branch main. After this command, it will not go down, it will go up again, and so on. If you are running this one, right, you always go back to the particular main label after the branch. So this is, they call it unconditional, because it, no matter what happens, it must jump to that particular level. All right, so this is the one. And here, go back to the one that we did just now. Here, when you have the branch over here, right, branch main, this is the offset. Basically, this is the offset that you are going to use. This is the value offset. Offset is here. Like, so for example, here we are going to look at the 8-bit displacement, which is the same one like this just now, right? All right, so you have the command here. This is the syntax different from here. This is my example. So no matter what, we are looking at the example first. So this is a program in EZ68K, start origin at 1000. So this is going to clear, and then this is branch to Muller. You see here, in this case, right, the branch for the offset is F8. In the program, it's already show you at the branch Muller line. This is where you can see the offset. So how you want to calculate this one is you must use back the formula here. The offset is equivalent to target address minus current program counter. So target address is what here? Target address in this case is 1000, because you are going to go back to 1000. Target address for branch is 1000. Okay, instruction, okay, current program counter is the instruction of your this one. Current program is instruction branch address plus 2. Instruction branch address is this one. Instruction branch address is this one. Okay, target address is this one. And then if you have the target address, you have the branch address, you can do the formula calculation here. Target address minus bracket instruction branch address plus 2. You must plus 2. Okay, that is the number that you have to put. So in this case is 1000 minus bracket 1006 plus 0002. This is the one just now. In hexa numbers, you must do this calculation, and finally you got this value. This is like a negative value. That means it jump back, go up, not going down. So you can get the last 2 digits here is the offset, which is the same value in the program. So if you look at this example here, right, we are going to look at the offset, which is F2. So how to do that one? Okay, how to do this one again? Let's look at the command that I have just now. So in the program, you can see the offset is F2. So we are going to try by looking at the example here. So you have the instruction, okay, branch address is at where? Is at this one, 100C, $100C, right? So you have the target address. This branch is going to target to where? To main. Okay, the main is 1000. And then you have the offset equivalent to the target address, which is $1000 minus, right? Minus this one is where you're going to have the instruction byte address is 1000C, $1000C plus $0002. Alright, so calculate this one. Okay, 1000 go for hexa numbers, 1000 tolak dengan 1000C plus dengan 0002 or 2. Alright, so you're going to get the answer is FFFF. The last one is F2. So $sign F2. So this is a case for the offset. Okay, so that will be the formula and how it will be calculated. So you can see the offset is given in the program, but you can prove it by using the equations. So same goes to this one. So in this example, right, in this example, you can see here the branch is starting at the beginning, branch going down. Just now is branch going up. So in this case, right, the branch target and the instruction of the branch will be different. And you can see from here, when you use the formula, right, it will show you the value of positive number, not FFF at the front. So this is 04, which is also at this branch particular, right, is given you where the value of the offset in this case is 04. This one, yeah, you can do the proof, or you can calculate back this one and you can get this one. This is to prove that this will be the offset, which is stated here in the line of the address. This is the machine code for the branch, right? And then we have the another example. This is just to show you guys if your program is very big, very long, right? So it can jump like for the 16-bit time displacement. So for example, just now, right, when we show you guys about this one, when you do the 16-bit displacement, it can displace very far away, very high, and based compared to the only to the 8-bit displacement. So 16-bit displacement is much further based on the branching. Alright, let's look at the result here. Okay, this is the same thing again. So the formula will be the same, right? So in this case, right, in this case, if you have the 16-bit displacement, you are going to have 4 digits of hexa. Just now it's only 2 because it's a 8-bit displacement. So you calculate back this one again because you can know that where's the address and where's target address. So based on this one, you're going to get AFFE. This is the 4 one. Is going to be the offset for this particular 16-bit sign displacement. So very clear, if you have the 16-bit displacement, it will be shown by 4 digits of hexa, because 4 digits is equivalent to 16, and the other one 8-bit displacement is only 2 digits hexa, which is 8-bit only. Alright, so that will be the unconditional branch, which we are going to talk about only the branch always. Alright, let's move on. Jump. Okay, jump is another one, unconditional, nearly the same like the branch, right? But the jump is unconditional instruction that causes execution to continue at any location specified. So any location specified, you can jump the thing. Alright, so it nearly the same like branch as now. This is jump, and then you're going to put the label or the effective address. So we're going to just try the jump. So any location in the entire address space may be reached with the instructions. You can jump anywhere in your program. Okay, in your, because you know that the program that you have, right? So how many it can work from the address, so you can jump anywhere. Just limited numbers of addressing mode. This is not, we're not going to touch for this one. So basically in our program, right, is rarely we use jump, but if you can look at the example in the internet for the program, you can see how they use jump. In this case, we can use back the jump statement over here, right? The jump syntax over here. So let's look at the easy CCAK again, this one. So instead of branch, right, you can just jump JMP. Right. So we run this one, execute. So when you run this one, you always go back to the main line, because it will jump back to main, because it can jump anywhere. If you are going to jump to somewhere else, this one, let's do this one. Just put Kuching. The label name is Kuching. Okay, jump to Kuching. Right. No issues. So run this one, and you only go to that particular jump line. This is just like a looping again. Alright, this is similar. Okay, let's move on.